Hello, good day, and welcome to the 7.4 concept guide entitled A Postulate for Similar Polygons. You'll have to excuse my breath. I had a lot of onions today at lunch, and, well, just hope that doesn't cause any problems. All right, the things that we've been doing so far lead us directly to this pretty short and sweet lesson. Last lesson we talked about that two similar polygons can be determined if their corresponding angles are congruent or if their corresponding sides are proportional. We're going to be focusing on the first one of these here today. Just like with the congruent triangles, that we didn't have to show that all the sides and all the angles were congruent to show that they're congruent. We had SAS, ASA, SSS, etc. Similarly, for similarity, there are easier ways. So we're going to start today by talking about the AA similarity postulate. You could probably guess what this is about to be about. Angle, angle. Triangles are similar if two pairs of angles are congruent. Let's talk about this for just a second. If we have two triangles, and let's say that we know that two of the angles are congruent. They both have an angle A, and then they have another angle that's called angle B. So therefore the AA part of this. Well, if we know that the other angles, let's call one X and the other Y, A plus B plus whatever the third angle is has to equal 180. A plus B plus X has to equal 180. A plus B plus Y have to equal 180. Well, what else has to be equal? The third angle, which means we have congruent polygons. Of course, congruent polygons means that the sides will then be proportional. So if you have two angles that are congruent, then the third angle has to be congruent, and then the sides, therefore, will end up being proportional. The polygons are similar. So the first set of questions that we'll end up answering have to do with this stuff down here. Tell whether the angles are similar or not. If you can't reach a conclusion, write no conclusion is possible. So let's look here at number one. We know that we have one congruent angle. There's 60 degrees. We know that if the other angle for the first triangle is 62, then the third angle has to be 58, and then the other is 54 and 66. So do we have congruent triangles? No, we do not. We do not have congruent triangles. I'd like for you to pause each of these, think about it on your own, and then I'll come back around and talk about it with you here. So pause, do number two. Okay, so did you discover that the third angle for the first one has to be 70, and then the third angle for the second one has to be 60, so therefore we have similar triangles. Pause and try number three. Okay, did you notice that we have two right angles, so we have one set of angles, and then we have vertical angles that are shared, so there's the AA. We have two angles that are congruent. Yes, these are similar. Pause. Try number four. Okay, so number four, we have two right angles, one right angle in each triangle, but what about the other ones? Well, we don't have vertical angles, we don't have corresponding angles, alternate interior angles that would be congruent, anything like that. We don't know. No conclusion can be made. Pause. Try number five. And what do we have here? We have two isosceles triangles. So if the first angle is 40 degrees here, then we have two 70-degree angles down there for the bases. For the second one, we have 75-degree angle, so we have 75 and 30 for the others. Are they similar? No, they are not. So there's three answers here if you're figuring this out. Yes, they're similar, no, they're not, or no conclusion is possible. Pause and try number six. Okay, on number six, we have two triangles. You see one little triangle inside the big triangle. And we have 45-degree angles. it would be helpful if we knew we had parallel lines. That would give us some corresponding angles that are congruent. But are they parallel? We don't know, so we can't say that we have corresponding angles that are congruent. It would also be helpful if that's a right angle, is this other angle a right angle? We just don't know what's going on here, so I think you can tell by my language here. No conclusion is possible. We only know that one angle is congruent, not a second one. Okay, the other type of thing we'll be doing out of this section primarily is solving for angles, using a little bit of algebra along with the similar triangle concept. If you'll notice this example that we have here, finding for x and y, the first key is finding the two similar triangles. Now, triangle ASR and triangle ACB. Now, are they similar? Well, because we have parallel lines, we have corresponding angles that are congruent. They both share angle A up at the top. So yes, we have similar triangles, not congruent triangles, similar triangles. They are similar. Now, something that's going to help you, especially when the triangles are kind of blended together, is to redraw them like we have over here. We have triangle ASR, triangle ACB, and notice this piece here, that at side AB of the big triangle has this piece that's 8, that's 4, that's where the 12 comes from. The 10 and the y create this side, 10 plus y. Now, the first thing you'll have to do is find the similarity ratio, which there's your 8, there's your 12 from AR and AB. So then we can set up our proportions. 8 over 12, AR over AB, equals side AS over AC. Plug our values in, 10 for AS, 10 plus y for AC, and solve the proportion. Cross multiplication, or the means of extremes property. Then work towards getting y by itself. Y equals 5. So we use proportions to solve these similar triangles. Now, let me point out a shortcut that we could have done. 8 over 12 was our similarity ratio, our scale factor. 8 over 12 simplifies to 2 over 3. So it'll save you, well, we'll just be dealing with simpler numbers anytime if you can simplify those ratios. So 2 over 3 equals RS over BC. So 2, 3 equals x over 15. And we have a relatively simple proportion here to solve. X equals 10. Go ahead and give these questions down here at the bottom a shot, and I'll display the answers here in just a moment. On number 7 here, the answer is for x is 4, y is 6. There's the shared angle up at the top. Also, do you see that there's two segments, two sides that are parallel because of the corresponding angles? On number 8, we got vertical angles here. X is 3, y is 10. On number 9, we have the parallel lines creating the corresponding angles, which means you've got to be a little bit careful here. The sides, or the angles that are congruent on number 9 are these. So, did you catch that? That was a tricky one. Anyway, check these answers out. If you have questions, of course, be ready to ask them. Or come see me. Be happy to help you. And make sure you get some rest tonight. I know you guys have been staying up late. Talk to you later. Bye.